Hello, we are here for one more lesson of this T-Flex CAD training course, and the topic for today will be the deformation. There are a lot of deformation operations inside T-Flex, and all of these operations allow the user to perform modifications of the solids and or sheet bodies by various means. We will see a couple of examples, and we'll try to explore with very easy and very fast models the several possibilities we have inside the program. To go to the place where we have all these commands, you know already, 3D model menu, and then under the special group we have this icon here, and we have all of these types. So the first one is something called the Skew. The Skew, it is this one, Skew deformation, and in this particular function the deformation is specified by displaying the vertices of the bounding parallelepiped of the given body. So I have this body here, okay, with already a shape. I go to the function. I need to choose my body, and now I get this parallelepiped which I can change by selecting the vertices, okay? And as you can see, I have my draggers which allow me to do a lot of things, rotate also, and do this kind of thing. So after I'm satisfied, okay, I click accept, and my model, it is changed. Then I have another similar function called the Sculpt, and for the Sculpt I have this model here, very nice vacuum cleaner or toy, I'm not sure. And in the Sculpt, the deformation function is defined by displacing the nodes of a regular mesh of one of the faces of the bounding parallelepiped also. So in the same place, I have a function called Sculpt deformation. I will choose my body. I get this box around my model, so I need to choose a face to change. So I want to deal with this face here, and I get these isoprometric lines and points which I can change, or if you want to call it better, the mesh size. So I can apply more points, and if I create more points, then what we change is more fine, okay? It's less rough. So I can say, for example, this line here, and change it according to this, okay? When I'm okay with the transformation, I accept, and I change my model also. For sure we have some options, more sides, I can change the density of the mesh, okay, I can deal with a lot of things. So these are details that you can explore also after this lesson with your sample models. Then we have also something called scaling or twisting, which I will use in this very simple shape. So if I go to the same place, I can call this function scale twisting deformation, and in this function I will choose my body, and I get these draggers which allow me to position. So if I go to my position start, I will enable this function here to deform the whole body. So I take them out, and I say, or I can say, the place where I want to act is from -50 to 50. And for example, I can insert another position, so in the middle. And now I can do two kinds of things. The first one, it is I can change this wheel. This is scaling. So if I accept, I can do this kind of deformation. Or if I do the exact same thing, but now with a twisting, let's try -50 and 50 here. And now let me twist this again and the other on the other direction, and we can do this kind of very nice shape under the twisting. So we have two functions in the same command. Then we have also another type of function call it the bending. And I have this initial shape. I can go there, do the bend deformation. I can choose my body, and now I get these draggers again, which allow me to position the place where I will deform. I know that this dimension here should be a little bigger, so instead of 250, 280, and I want a radius here of 80 with a 90-degree angle, and just confirm, and we get this very nice shape also with this umbraco key that you probably have already dealt in your personal life. The last one, it is something called the deformation by curve, and it's also a very nice command. There are tons of examples that allow the user to see and to make very powerful models, but I will use this very simple shape. And what I've created to prepare this command was a simple cylinder. I put a curve in the center or in the axis of the cylinder, a local coordinate system in the base, and this curve defined by 3 nodes with a local coordinate system also in the start point. So the idea now it is to deal with the deformation by curve. And first step, choose your model, then choose the source curve that will be the axis I've created. Then we can define a source coordinate system, which is this one, and the target curve, that is going to be this one. Finally, I will choose my target coordinate system, and you get this orientation of the coordinate system that allows us to position the directions according to what we have already in my source curve. So if everything it is okay, and I have a couple of different functions, I'm using this first one, 3D curve to 3D curve. I can do this a curve to a spiral or 2 curves. Each one of these have different parameters, but this is the basis for understanding this command. After everything it is selected, what we expect is to convert this shape going through this curve. So let us confirm, and as you can see, okay, the shape follow the curve we defined in the target curve. There is one more function called the deformation by surface, which we are not going to see. there will be a special video for this function in specific. For the moment, I invite you to see the theoretical side of the course, because you have detailed explanation about this particular function. It takes a little more time, and I think goes a little out of time in this particular video. So for the functions we've seen, any questions or any specific points that maybe were not so clear in this video, send us an email or give us a contact, and we will help you according to whatever you may need.